How do you feel about all that?
I'm pretty good, actually.
Okay, good.
Oh, no.
Wait, what do you mean I know?
Okay, you feel good about that. So what comes next, though?
Well, I mean, if you feel good about it, we're going to keep pushing you, right? So, here lies the question. We're pretty good at picking the function. I want to give you a framework for how exactly to more general guidelines than that in a moment, but try this one for me. This is pretty similar to the one that we did before, but you'll notice, just as a hint, something interesting kind of happens when you try and do it.
There's no like multiple stages of this, right? Like you'll have to do one, and then you'll have to take the integral of one of them and just do the whole process again with that.
Oh, you mean like the first time that we saw it? Like, remember how the first one, when we picked the wrong one?
Yeah, we picked it, and there's no, like, there aren't going to be any cases where they're both wrong, but one of
They're both wrong. As in, like, no matter which way you do it, you're incorrect, kind of.
Well, no matter which way you do it, there's something even still complicated, so you have to repeat the process with that thing.
But how would that work? Would you just keep going on, do you reckon?
To the negative x. Okay. I don't know. Okay.
It would be interesting.
Because this one, I'm not sure I'm seeing anything. So
walk me through your process. What do you think?
Okay, so I always just start by seeing what happens if I let u equal to x squared, which is probably going to be wrong this time. And I do think, so I guess I do a trial and error sort of way.
Yeah, I mean, it's not necessarily a bad way to do it, but I guess while you're doing the trial and error in the early stages, have a think about what you're noticing in terms of which ones are better to choose. Those are your guiding principles.
Well, a single x to the power of 1 is usually...
is a good one for you, yeah.
So that's 2x.
Yeah.
B dash is 2x. B dash is e to the negative x. So b will be negative e to the negative x.
Okay.
Which doesn't really... That puts us in...
So we get what? What's our VU? We get x squared. Take our integral of negative e to the negative x, 2x.
Yeah.
Not great.
It's not great. But what if we further integrated what was there through integration by parts?
Okay. So what would you do then?
Well, you take the... Okay, this is probably the wrong way to go down.
Sure. Let's roll with it.
This is what I was thinking of before.
Yeah.
Because then if you let... Let's make two variables, a and b.
Okay, sure.
And if a were equal to negative 2x...
Yeah.
Oh, no, it doesn't matter. You can just take the negative out. So, just make that a plus.
Yep.
So a is equal to 2x.
Okay.
A dash is equal to 2.
Nice.
And then we start to see something more simple, don't we?
Yeah, that's better. I like constants.
B dash is equal to e to the negative x.
Mm-hmm.
So b is equal to negative e to the negative x.
Perfect.
And from there, we substitute all of that right in.
Mm.
So we get equals negative x squared e to the negative x.
Yep.
Plus, what is it, a times b? So 2x, or negative 2x e to the negative x.
This is getting very nice now, isn't it?
Yeah,
So, a times b, so 2x times negative. So I want to say that's negative 2x e to the negative x. Okay.
Minus the integral of negative 2e to the negative x. Have I done that right?
Mm-hmm.
Which is possible.
That is possible, isn't it? What is that?
I feel like there was a better way to go about this.
What does that become? Let's get going.
Oh wait, why is that a plus?
There are two negatives. Yeah.
Okay.
Yeah. And then this...
Negative x squared e to the negative x. We're going to start with that. Or are we going to...
Where do you want to start, sorry?
I was just starting what was on left-hand most.
Yeah, yeah.
Negative x squared e to the negative x.
Mm-hmm.
We'll go minus 2x e to the negative x.
Yep.
I'll look for simplifying terms later, but I'm not sure how possible that's going to be. Plus the integral of that, which is... Hold on, give me a sec. Because it's weird for integration. Oh, not that weird. Negative 2e to the negative x.
Looks good to me.
And then you remove that plus because it's
Okay.
plus and-
So that's our answer.
Well, I mean, there's a few each of the negative x's you could
Factorize.
now.
Okay.
Um,
You can't factorize that x because,
yeah, there's the final ones. So yeah, I suppose if I'm looking purely from that perspective, that's my answer. Maybe I could possibly factorize with, I could take out a negative.
While we're at it, hey, why not?
While we're at it. I don't know if that can be further factorized. What's the discriminant? I don't care to find out.
You're not about simplifying. It might surprise you to realize that that is actually the method that
Really?
most people use to do that.
Oh,
yeah.
that most people use.
Yeah.
Wait, so is that the method you wanted me to
I think, well, that's the method that I would use to solve it. There are situations where, in fact, as you said correctly, you actually have to apply the integration by parts multiple times in order to get to a result. So even if you get to this situation, you think, oh, hang on, that's a bit strange. Why do I have to do this again? In fact, you're correct. You actually have to apply multiple applications of it. in order
Okay,
to
so
do
there wasn't an easier way to do that.
that is the easy way to do
Wow,
it.
okay.
Jot that down. That's good.